here? So today is focusing on midpoint. So in section 1.3, it does review distance and then midpoint of a segment. So starting out with a definition, the midpoint of a segment is a point that is halfway between the endpoints of the segment. So exactly in the middle, midpoint, middle. And then I do have below, so this is going through some notation as well. So it says if X is the midpoint of segment AB, then let me actually draw this out and we'll fill those blanks in. So say I have segment AB, so my endpoints are A and B, and X is the midpoint. So X is directly in the middle. What that tells me is that this segment AX and this segment XB, those segments are congruent, their measures are equal. So I could mark that on here. Maybe I'll use a different color. To mark that, I would just put kind of a line on both segments to show AX is congruent to XB. And that's what I want to write in these blanks. So then I know segment AX, so you do need the bar above it, segment AX is congruent to segment XB, and that means that the measure of AX, which again you just write as AX without the bar above it, is equal to the measure of XB. So just having you fill in to practice and hopefully better understand that notation. The segments are congruent, meaning their measures, their lengths are equal to each other. And just like we looked at distance yesterday, when you have a number line versus in a coordinate plane, we look at midpoint the same way. So on a number line, if we have segment AB and it has endpoints x sub 1, x sub 2, so just two different coordinates, then the midpoint M, or whatever variable they tell you in the problem, sometimes they don't give you a variable, you don't have to put a variable with it necessarily, is calculated this way. So it's adding x sub 1 and x sub 2 and then dividing by 2, and then there's a visual of that below for how to calculate it. So that's a formula that you need to know and know how to use. So this formula, what you're actually doing, this is the mean, or another word for that is the average of the coordinates of the endpoint. So when you find the average of two numbers or the mean of two numbers, you are finding the middle of them, which in this case would be the midpoint if you have a number line. In a coordinate plane, so the next box over, if we have, now in this case, segment PQ, and these are the ordered pairs of the endpoints, similar to what you saw yesterday. So remember the subscripts of 1 and 2 are just to differentiate between the x and y values. You can think of the 1 as P is the first ordered pair, Q is the second. The midpoint M has these coordinates. So notice it's very similar to on a number line, the x coordinate. All this shows is you're taking the average of the x coordinates and the average of the y coordinates, and then that ordered pair is your midpoint on a coordinate plane. And you've probably seen the midpoint formula before. And as it says, the order of the coordinates, the order of the x1, x2, y1, y2, that does not matter. So if you flip them around, you're fine, as long as you have the x's together and the y's together. So we're going to go through some examples not only of finding a midpoint, but then also some different types of problems with it. Maybe you're given the midpoint and you're trying to find one of the endpoints. That can happen. So in example 1, it says the temperature on a thermometer dropped from a reading of 25 degrees to -8 degrees. Find the midpoint of these temperatures. So if you are more visual, you could actually put this on a number line. You could draw a segment where on one end, the lower end, you have -8 degrees, and the higher end, you have 25 degrees. If you kind of want to visualize it like we have this visual up here, that might help. So we are trying to find the midpoint. So we want to know what number is exactly in the middle of -8 and 25. So we can calculate it using this formula here. So the midpoint would be if I added these two numbers numbers together and divided it by 2. So negative 8 plus 25, all divided by 2. Bless you. And then I just calculate that. So negative 8 plus 25, that is 17. And then 17 divided by 2 is 8.5, 8.5. So it would be 8.5 and then degrees, since those numbers were labeled in degrees. Okay, so another word for average, it could be referred to as the midpoint, but it's asking you for the average. Okay, and then if we look at example 2, here it actually gives you the number line with 4 different points on it and says use the number line to find the coordinate of the midpoint of each segment. So if you look at A, we have segment AC. So I'm looking at where A and C are. A is at negative 12, C is at 6. So I calculate it the same way I did example 1. To find the midpoint, I'm finding the average. So I would add the two numbers together, negative 12 plus 6, and then divide it by 2. So negative 12 plus 6 is negative 6, and negative 6 divided by 2 is negative 3. So the midpoint for segment AC, or the number that's exactly in the middle of those two numbers, is negative 3. Okay, so go ahead and calculate the midpoint for the other two, for segment BD and segment AD, and we'll just double check that we are getting the right midpoints. Stop me as I'm walking around if you have a question or would like me to check something. Otherwise, I'm just making sure you had a chance to answer both of them. You can check with those around you as well, see if you're getting the same midpoint. If not, compare and see why. Okay, check what you have. You should have for segment BD, the midpoint is positive 9. Segment AD, the midpoint is positive 3. I have my work up there if you didn't get those. And you can compare with the work you had. So again, make sure with average you are adding the two numbers, not subtracting them. Yesterday with distance, we were subtracting them. Questions on midpoint from a number line? Okay, because now we move into midpoint on a coordinate plane, or when you have actual coordinates ordered pairs to find the midpoint. So example 3 says find the coordinates of M, the midpoint of segment ST, for F being the ordered pair negative 6, 3, T being the ordered pair 1, 0. Okay, so this is where we're using this formula here. So you are getting an ordered pair. The midpoint of two ordered pairs is another ordered pair. And notice again in this formula, the x coordinate is the average of the two endpoints. The y coordinate is again the average of the two endpoints. So I'm just going to label, if you wanted to actually put x1, y1, x2, y2, I'm just labeling, if that helps you, make sure you know which ones are x, which ones are y. So for the midpoint, I can say m equals, since they did give me the variable for the midpoint, I'm going to put a parenthesis because I'm writing an ordered pair. My x coordinate is the average of the two x coordinates, which are negative 6 and 1. So I would take negative 6 plus 1, all divided by 2. I'll calculate that, but that's my x coordinate. And I put a comma in between. Now I'm going to write the formula for my y coordinate. It's the average of the two y values, which are 3 and 0. So 3 plus 0, all divided by 2. And then close the parentheses. So I'll get an ordered pair. Okay, and then I just calculate. So for my x-coordinate, I know negative 6 plus 1, this is negative 5. And if I divide negative 5 by 2, I would get negative 2.5. So that's my x-coordinate. For the y-coordinate, I know 3 plus 0 is just 3. 3 divided by 2 is 1.5. So the midpoint is the ordered pair, negative 2.5, 1.5. Any questions on that one? Okay, so if you flip it over example 4, here's a chance for you just to practice one, make sure you understand that formula and can use it. Find the coordinates of the midpoint of a segment with coordinates A and B as the endpoints. So you're finding the midpoint of segment AB is this would be the segment. So practice using that formula on your own. If you have questions, let me know. And make sure you are writing in ordered pairs your answer. Okay, I was just double checking. Make sure when you are writing an ordered pair that you do put parentheses around it. So that might seem like not a big deal to you, like, oh, I just forgot parentheses. If you don't put parentheses, you don't actually have an ordered pair. You just have two numbers separated by a comma. So notation is important in math, especially in geometry. How you label things is important. So it should be 0.5 or 1/2 if you left it as a fraction, 10. So ignore my 0, I wrote the wrong value at first. It should be 10 for the y coordinate. Okay, examples 5 and 6. We're for sure going to go through example 5. This is now still using the midpoint formula, but you're using it differently because you're given the midpoint and you have to find one of the endpoints. So it says the coordinates of the midpoint of JL is -1, 2. So this ordered pair, -1, 2, is the midpoint. So you could call that, I know they didn't call it a variable, you could call that M. The midpoint M is -1, 2. So I'm actually going to write that here. Anytime if they don't give you a variable for the midpoint, you can call it M. That's fine. And then JL are the two endpoints. So it does give us L. L is 3, -5. But we don't know what J is. We don't know the other endpoint. So for right now, I'm just going to call J the ordered pair x, y. I don't know what the x and y coordinates are. I'm just going to put x, y. So I'm still going to set this up using my midpoint formula. Okay, you just have to make sure you are setting it up correctly with your endpoints and then your midpoint. So if I were to set up an equation for my midpoint here, these are my two endpoints. Okay, so to find my midpoint, I would take the two x values and add them together and divide by 2. So I would have x plus 3 all divided by 2. And then same thing for my y coordinates. I would add them together and divide by 2. So I would have y plus -5 all divided by 2. And then that would equal my midpoint. And I know what my midpoint is. My midpoint is -1, 2. Okay, I'm looking for x and y. So I can actually now set up two equations to solve for x and for y. So let me just get a highlighter here so you can see this. I know that this expression must be equal to -1 because I know what my midpoint x value is. I can set that up then as an equation. I can say x plus 3 all divided by 2 must equal -1. Okay, now I can solve for x. What would I do in this equation first to solve for x? I'd have to, get rid of the 2. I'd have to multiply by 2 on both sides. So then I still have x plus 3 equals -1 times 2 is -2. And then what's my next step? Solve for x, I'd have to do what to both sides? Subtract 3. So then -2 minus 3 means x is -5. Okay, so I now have the x coordinate of the ordered pair I'm looking for. My x coordinate is -5. I still need the y coordinate, but I can set up a similar equation to find the y coordinate. So now I know that this expression, y plus -5 divided by 2, that must equal 2. Okay, this is my second equation. Y plus -5 all over 2 equals 2. Just to help you see where this is coming from, I'm trying to color code things here. Okay, I can solve it a similar way then. I still have to do my first step of multiplying both sides by 2 to get rid of that fraction. So multiply both sides by 2. And I have y plus -5 equals 2 times 2 is 4. And then what would I do next to solve for y? Add the 5 because it's negative, yep. So then I'd have y equals 4 plus 5 is 9, so my y coordinate is 9. So the coordinates of the missing endpoint are negative 5, 9. Okay, are there questions on that one? Okay, so I actually, because I do want to leave time for you to work on the assignment. So example 6 is just like that one. I'm going to skip over that for right now. And I want to go through example 7. 7 and 8 are also very similar. So I'm going to go through 7 with you. 7 is still using the idea of a midpoint. It says find the measure of segment PQ. So we're figuring out how long that segment is if Q is the midpoint of segment PR. Okay, so if Q is the midpoint, we talked about the idea right at the beginning. What that means then is PQ and QR are equal to each other. These segments are congruent. So therefore, if I have expressions for each of those segments, I know they must be equal. So I know PQ is going to equal QR. You wouldn't have to write this down necessarily. I'm just showing this to show why I'm setting up the equation the way that I am. So that means the expression for PQ, 9y minus 2, must equal the expression for QR, 14 plus 5y. Okay, those must be equal to each other. I can now solve for y. Once I know y, I'm able to find the measure of PQ like it's asking me to. So how would I solve this equation for y? What could I do first? Subtract the 5y. Nine y minus 5y is 4y. Bring down the minus 2 equals, I still have 14 on the other side. Plus the 2, add the 2. I'm going to continue this up here. I still have 4y equals 14 plus 2 is 16. And then I would have to divide by 4. So y is 4. And again, like I mentioned, that's not our answer. So be very careful, especially in geometry. A lot of questions, you will have to find a variable, but that is not necessarily what they are looking for you to answer. You then have to figure out what they wanted you to answer in the first place. We needed y so that we could find the measure of PQ. So now I have to substitute that back into this expression. So PQ is going to equal 9 times y is 4 minus 2. And then I evaluate. 9 times 4 is 36, and 36 minus 2 is 34. So the measure of PQ is 34 units. It doesn't give us units, so you don't have to put units after it. Okay, questions on that one? So understanding midpoint means, or is halfway between, meaning it creates two congruent segments. So 8 was just like that as well. Again, I want to leave time for you to work, so I want to talk about this idea down here that is at the very bottom. This is more notation and vocabulary. And these blanks for you to fill in. This should say any segment, line, or plane that intersects a segment at its midpoint is called a segment bisector. Okay, so that's an important term. So Any segment, line, or plane that intersects a segment at its midpoint is called a segment bisector. So it bisects the segment, it cuts it into two congruent pieces. So in the figure that is here at the right, M is the midpoint of PQ. So it shows that plane A and then segment MJ, line KM, and point M. Those are all bisectors of segment PQ. Since they are all going through point M, they're all bisectors. So we say they bisect that segment. So that's kind of the terminology that goes along with it. So as we build and as we get into proofs in geometry, if you've heard that in geometry we go through proofs, these ideas, making sure you have an understanding of that vocabulary is very important. So your assignment is down here. And I will pull up the textbook on my screen while you're working in class. You're free to pull it up on your own computers as